All right, we are looking at finals review day 6, modeling quadratics. All right, you'll see up on the screen, we have our TI 84 plus calculator, as well as some tips and tricks about how to find vertex, y-intercept, x-intercepts, centers, how to center the window, draw a box, zoom in, zoom out. We're going to go through all this stuff, but it's good to have as a reference. So if you need to pause the video and take some notes on these, please do so at this time. But we are going to jump right in. And we're going to look at important points of a quadratic. Hopefully this is a good refresher. So there's a couple points that we need to pay close attention to. And the first that we're going to talk about is the y-intercept, all right, which also refers to our starting height. So this will always be 0 and then a number, and that y value will always be height, and it is the height of the object before it is put into motion. And this could vary, so make sure you pay close attention to what the problem is asking you. All right, so that is the starting height. That is your y-intercept. Next, we have our vertex, which is definitely tells us some important information. First off, it tells us, for its x value, how long it takes for an object to reach the highest point while in motion. And then the y value of the vertex is how high the object will go. It is the maximum height. All right. Last but not least, we have the x-intercept. And what the x-intercept tells us is we're going to pay attention to the x value because the y value here will be 0 and our object will have hit the ground. And it is what it represents is how long an object is in the air before hitting the ground. So we have our y-intercept for starting height, we have our vertex, and our x-intercept. If you need to pause the video to take some notes, I recommend you do so. So we're going to jump right into a problem. All right, this is from your packet. We are going to do this together, and we are going to get started. So you are standing on the balcony of your house and tossing a water balloon into the air. The water balloon can be modeled in feet with x by the quadratic function below. F of x equals negative 4.9x squared plus 10x plus 12. All right. First thing that I am going to want to do is I'm going to throw this right into the calculator. So I'm going to go over to my calculator. I'm going to hit y equals, all right, and I'm going to do negative 4.9x, and then I'm going to square it, and then I'm going to do plus 10x plus 12. Pay close attention to the buttons that I just hit. If you need to rewind the video, please do so. After I plug this in, I'm going to hit graph. As you will see, my graph does not fit the box or the screen. So I'm going to have to make some adjustments to what I'm looking at. So I'm going to hit my zoom button, and I'm going to zoom out. All right, and I can just hit enter after that, and it will zoom my graph out. Now it's too small. So what I will go back and do is hit my zoom key again, and I will do Z box. And I always want to go below the x-axis, all right, and over to the left a little bit to make sure that I fit my graph. I'm going to hit enter, and then you will see my square box will start blinking. And then I'm just going to hold it to go up, make sure I include the top of my graph, and then I am going to hold the arrow key to the right so I get everything, and I will hit enter. And now I've got a really good look, and my graph fits the entire screen, and I should be able to work from here. Now, the question in this problem is, what is the maximum height the balloon will reach after it is thrown? Keyword, maximum height. Okay, that tells me that I am going to be looking for the vertex. All right, the vertex is going to tell me how long it takes to reach the maximum height and how high the object or the balloon reached. So what I'm going to do is I'm going to do the following. and it's here at the bottom. I'm going to look for my vertex. All right, so pay attention to what I click on the calculator. All right, so we are going to go to second, trace, and I'm going to look at what the maximum is. The maximum means the highest point of my graph. All right, so I'm going to hit enter, and then you're going to see I'm going to have a cursor blinking on my calculator screen. Now it's asking me for the left bound, so I'm going to go to the left side of my vertex. Doesn't matter really where, just make sure that it is on the left side. I'm going to hit enter, and now it's asking me for the right bound, and I'm going to go past the vertex on the other side. Just doesn't matter really where. You can go down, you can go up. Just make sure that it is past the vertex. I'm going to hit enter, and then it's going to say guess, and I'm going to hit enter again, and two values are going to pop up at the bottom of the screen. All right, there's going to be the x value, which says 1.02. What that tells me is that this water balloon is going to take 1.02 seconds to reach its maximum height. And then the y value, which is always going to be height, is 17.1. This tells me that this water balloon will reach a maximum height of 17.1 feet. This tells me that my answer for this particular problem will be B, because it is asking what is the maximum height the balloon will reach after it is thrown. Alrighty, let's move on to the next free response example problem. All right, I'm going to go back to my calculator. I'm going to clear this out. All right, and back to my screen. So we have a firework is being set off the roof of a tall building, but it's a dud and falls to the ground. The flight of the firework can be modeled by the quadratic ht equals negative 5t squared plus 30t plus 25, where t is the time in seconds and ht is the height of the firework. First thing we're going to do, and this is actually something that you're going to want to do each time you do one of these problems, is sketch a picture of the problem above and label the y-intercept, the vertex, and positive x-intercept. All right, so I'm going to pull up a rough example of a drawing that I did. It's not going to be perfect. I have labeled over here my y-intercept, I have my vertex, and I have my positive x-intercept. And I know if I need to rewind this video, I can know what each one of these stands for. All right, so now I'm going to go ahead and I'm going to graph this. Now I'm going to do negative 5. I'm going to replace my t's with x's. Negative 5t squared plus 30x plus 25. And I'm going to go ahead and I'm going to graph it. Now that does not fit. So what I'm going to do is I'm going to zoom out. And it doesn't fit again. So I'm going to hit enter again to zoom out some more. Now I really can't see it, but I'm going to hit my Z box. I'm going to come over a little bit, hit enter. I'm going to go up and I'm going to make sure that I've included my graph, and I'm going to slide it over, and I'm going to hit enter, and boom, I have got enough of a visual of my graph that I can determine some key information. All right, so it is important for you to be able to do that, hitting the zoom. And if you need to rewatch these parts of the video, please do so. All right, so the first thing I want to do is I'm going to find my y-intercept. I'm going to go from left to right. Now, according to our cheat sheet, what we can do for that, all right, is we can actually just hit trace for our y-intercept. All right, and we can just type x equals 0. We want to know when this graph crosses this line. So we can hit trace and then 0, and we can hit enter, and bam, my cursor is now on 0, 25, and that tells me that my y-intercept, and I'm going to label that on my sketch, all right, that is the starting height. That is how far off the ground this firework is being set off on top of the building. All right, so I have that. Now I want to find my vertex. We just did this on the previous problem. So I'm going to go to second, trace, Now I'm going to go to maximum, which is 4. All right, and I need to remember, I need to just make sure that I'm on the left side of my vertex, and then I hit enter, and then I go to the right side of my vertex, and then I hit enter, and then I can hit enter again, and there you have x and y value. I can round this x value to 3, and my y value will be 70. All right, so that tells me after 3 seconds, this firework will reach its maximum height, and the maximum height it reaches is 70 feet off the ground. All right, next, I want to be able to find the x-intercept. All right, so the x-intercept, I'm going to hit my second key. All right, I'm going to hit my trace button, all right, which will bring me to calc, and then I want to go down to 0. All right, now what I want to do is figure out where this is going to cross this x-axis, the x-intercept I want to find. So I'm going to go to the left side, and then I'm going to scroll below the x-axis and hit enter. And then I'll have my 2 arrows there, and I'll have the blinking cursor. I will hit enter again. All right, and I'm looking at this first number right here, and it's 6.74. All right, and what that is going to be is where this line crosses the x axis. So the firework will hit the ground after 6.74 seconds. All right, so now I can answer my questions. Well, for B, it says, what was the starting height of the firework? Well, I can look no further than my y-intercept, which is 0.25, so 25 feet off the ground. For C, how long was the firework in the air for? Well, let's look. Firework was set off on top of the building. It reaches its maximum height, the vertex, and then it hit the ground. That 6.74 tells me some time, and that's how long the firework was in the air for, which is 6.74 seconds. For D, what was the firework's maximum height? Well, maximum height, all right, I'm going to look at my vertex, all right, and height will always be my y value, and I know that it is going to be 70 feet off the ground when it reaches its maximum height. Hopefully this answers some or all of your questions. If you need to rewatch parts of this video, please do so.